Hello all, welcome to another routing and switching video series. It's going to be very exciting today. Today we are going to discuss something about configuring iBGP and eBGP. iBGP stands for internal BGP and E for external. So we're going to configure iBGP and eBGP. As you see, I laid out the simple diagram here. If I expand this a little bit. So what we have here, we have on the top router 1, router 2 here. Let me highlight this: router 1, router 2, router 3, router 4. We have router 3 here and router 5. So what we will be doing in this video, if I let me select a different color here. So we would be configuring and this anything inside this red zone will be configuring iBGP. There you go. Hope that is clear. I'm using my mouse to write that, by the way. All right, and on the blue here we would be doing eBGP. eBGP. This is the best I can write using the mouse. All right. Okay, so for the iBGP, this is the condition. So in this video, I'm going to talk about how different iBGP and eBGP behave and how we configure them, right? So well, BGP itself is a very deep ocean, but I'm going to cover a basic and a little bit more than a basics, right? How the routing behaves and how we're going to configure iBGP and BGP and what are the different commands. So if starting for talking about iBGP, what I'm going to show you, we will be configuring iBGP based on the loopback interfaces. These guys, loopback 1, 2, and loopback 3, and eBGP will be configured between point-to-point IPs. These guys, right? So what I'm saying here is, for BGP configuration, doesn't matter iBGP or eBGP, you need to have a point-to-point connectivity. Either it's in a static route we have here, like 192.168.1.1 and 2, or you could have iBGP configured on the loopback interfaces. Well, if you have the loopback interfaces, either the router 2 should be able to talk to router 1, right? And that's not going to happen without any type of static route you put in there, RP route command, or we run any IGP protocol like eIGRP or Ospf or IP, something, right? Basically the router 2 should know how to get to router 1, and router 3 should know how to get to this IP address 1.1.1 on router 1. Same way, the router 1 should also know how to get to 2.2.2 and 3.3.3 on router 3. So to achieve that, we need to have either a static route configured or some IGP protocol configured. So what I'm going to do is I'm going to configure Ospf here. Just excuse me for my writing here. So let's go ahead and get started. First we'll configure the Ospf, then we'll advertise our loopback interfaces, so that router 1 should have a reachability to router 2 or router 3 loopback IPs, and same way, the other way around for router 2 and router 3 should know the loopback interface reachability on the router 1. So once we have that at the reachability, we will configure the iBGP. Once the iBGP part is done, then we will configure eBGP. So the end game is this guy router 4 should be able to ping router 5 static, the loopback interfaces or network sitting behind it. They don't have any physical connectivity in between, so that will happen this way. To reach router 5, router 4 will be going to router 2, then it's going to go to router 1, then going to router 3, and this way. As we don't have a direct connectivity between router 4 and router 5, so that's how we're going to reach to the router 5. And same thing, the router 5 would be taking the multiple hops to reach to 400. It will go to router 3, router 1, then router 2, then all the way to the router 4. All right, so enough talking, let's get it started. Let me take to my console here. As you see, these are my networks I just configured on router 1. My loopback IP is 1.1.1 and 1.2.1 and 192.168, 1.1, 158, 1.1. My static IP is connecting directly to my routers. Right. So if I ping to my loopback IPs on router 2, 2.2.2.2, I don't think I would be able to do that, as we don't have any IGP running between these two routers, right? So that's, we don't have the route basically to 2.2.2, and to configure iBGP or eBGP on any IPs on peer IP, we need to have the reachability. Now we don't have that. So if I do a show run in ROUTE, I don't have any static route configured here either. So let's do this, right? Const outdoor router Ospf 100, right? Let's put on the process ID 100. Then instead of typing all that network commands, I'm going to do simple network 0.0.0, and let me copy paste this from here. Oh, sorry, area. Let's put them into area 85. All right, and true IP Ospf neighbor. Obviously, nothing will come up. And I would show run sec Ospf. I will just copy this and I will put this command to make our life easy on router 2. Basically, we are configuring Ospf 100 process ID 100 on area 85 between all these routers, right? All right, so let's go ahead and connect FT. There you go. And router 3 connect FT. By the way, as you see, I have this networks configured on my router 3, router 2, router 1 as well. So let me go and copy this guy one more time. Go back to router 3. Alright, there you go. So let's hop onto the router and see what Ospf membership we have found. Show IP Ospf neighbor. Right, let's give a few minutes, few seconds I would say, for Ospf to fully come up. So we have found Ospf full neighborship for router 3. Router 2, I think it's already done. Alright. So now you see on the router 1 we have full Ospf neighborship between router 3 and router 2. If I ping the loopback IPs of router 2, 2.2.2, I should have reachability, as well as if we ping the loopback IPs on router 3, 3.3.3, I should have full reachability. Now that I'm able to ping, I'm not going to log on, hop onto router 2 and 3 and try to ping other way around, because this confirm two-way traffic, right? Okay, so now that we have reachability on our loopback IPs, it's a good time for us to go and configure the iBGP peers. Alright, so let's go with conft router BGP 100. The AS number is 100, by the way, as you see on all these three routers. Router BGP 100, neighbor 2.2.2.2, remote AS 100. Then I would also like to put the description to keep it neat and clean. Description route 2. Then I will just up arrow and change this statement. 3.3.3 remote AS 100. Description R3. End of the story. Show run sec BGP. Alright, let's see what happens. So this is my BGP configuration, right? So let's go and if I do show IP BGP summary, nothing will be up. Show BGP summary. Right, active state, because we still need to go and configure the BGP on router 2 and router 3. Alright, so let's go and do that. Conft router BGP 100, I will say, and then neighbor 1.1.1 remote AS 100, because they are in part of iBGP. So I also forgot to give another command here. Update source loopback interface 0. Anytime we are doing the BGP pairing based on the loopback IPs, right? You need to put this command update source loopback 0, otherwise the BGP might not come up, right? So and show run set BGP. I always like to confirm my BGP configuration what I have put in, so that it makes easier to troubleshoot to see if we missed anything while configuration. So I recommend to make a habit of doing that, just to verify pre and post everything. All right, so let's go back to router 1 and see if anything has changed. So as you see here, the BGP has formed for our peer 2.2.2, the router 2. Let's go ahead and configure the BGP for router 3. ConFT router BGP. Alright, neighbor. What was that? 1.1.1 remote AS100. Description router 1. Update, go back. 0. And should run sec BGP. Alright, let's see what happens if we form the BGP on the router 1 for our peer 3. So let's clear the iBGP session, clear iBGP soft. I would suggest you be careful using this command in your production environment. Alright, so the BGP is up, and let's see what is my routing table. Show IP route. Alright, now that we have Ospf as well as BGP, you'll see router 1 is learning the 2.2.2, 1.1 and other loopback interfaces 20.20, 30.30, etc. on Ospf here, right? As you see, O stands for Ospf. Alright, so let's do, now that we have iBGP, I would put one command so that we learn these routes on BGP instead of Ospf. So if I go here, show run sec BGP, I will go to my router BGP process is number 100. I'll say redistribute connected, and I would do the same thing on all routers. If I do this, show IP route, show IP route. And one second, let me. I just recall something important to cover. So before I get that redistribute connected here, as you see, when I gave the show IP BGP summary command, our BGP was up, but we were not learning any prefixes. Nothing were learning because I did not had this neighbor redistribute connected command given, right? So now that we put this redistribute connected and see what happens, right? On to the router 3. So 1 second here. Show IP BGP summary. So from my peer router 1, I'm running 4 routes, right? Right, and show IP BGP summary. Let's do here. From my peer router 2 and 3, I'm not learning anything because we are not advertising anything in the BGP, even though we have Ospf running as the underlay, as a IGP protocol, but BGP it's not running any route on the BGP, right? So like I said, it should run this BGP. I'll give this redistribute command. Redistribute connected. So basically what this command does, it distribute all the directly connected interfaces into BGP routing table, right? And let's go to the router 2, connect router BGP 100, redistribute connected. End of the story. Let's clear the BGP. I don't think we need to. Let's do this show BGP. All right, now you see the difference. As soon as I give a redistribute connected, I'm running all the 4 prefixes from all those peers now. All right. So if I do the same thing, show IP route. Now you see that we are learning the 2.2 loopback IPs in the via BGP now. Earlier it was on the OSPF. Sorry. All right. I hope that so earlier we were learning that on OSPF, right? So now we just switch them to the BGP, right? And let's try pinging 3.3.3.3. We should be able to ping, and 30.30.30.30. The loopback IPs of router 3. Yes, we have full reachability. And before we proceed, 20.20.20.20, we have full reachability to router 2 as well. Now that we have established iBGP between router 1, router 2, and router 3, and we are receiving all routes, we are good to proceed with eBGP. And before we move that, let's see on the router 3 if we are receiving the routes from router 2. Sure, right? Let's do show IP route. So we have 20.20.20 from router 2 being learned here, but it's coming on OSPF, right? Because if you the administrative distance on OSPF is 110, and for iBGP it's 20. Sorry, iBGP is 200. That's why it's preferring the OSPF over iBGP, because the iBGP is 200 and OSPF is 110. So that's why it is preferring the OSPF to as you see here, 110 over iBGP. If it was in case of eBGP, it would have learned those routes. I mean, there are multiple configuration we can do if you choose to prefer BGP over OSPF. But on the sake of this video, I'm not going to do that. But that will be definitely a topic for another video. So this video, we are only going to configure iBGP and eBGP and make sure we have full connectivity. And router 4 should be able to reach router 500. So basically it will be taking multiple hops, eBGP to iBGP, iBGP to OSPF, I'm sorry, then to eBGP again, right? Going this way around. Right, so let's go here. Let's hop on to the router 4, this guy, and can bring our eBGP between router 2 and router 4. So I will say, let's see if I have a configuration here for BGP. I don't think so. Alright, so eBGP, I'm not going to form appearing on the loopback, because the first condition is I should have connectivity to the loopback interface, right? Ping, if I say 444, sorry, not this, 2.2.2, my bad. I don't have any route to 2.2.2, right? I mean, I can configure a static route, and sorry, I got distracted. There is a text on my phone. All right, so we can configure a static route on and just have reachability on 2.2.2, or the simple way I would do is, now that we have point-to-point connectivity 172.158.1.0 and 1.2, right? Let me show you what I'm talking here. 172.168.1.1. That's the IP address of router 2 here. I have connectivity. Sorry, type insert IP address. Let me fix that. Come on. Right, so I'm using the static route point-to-point connectivity to form a BGP peering, right? So once again, for people who are not aware of that, BGP, to form a BGP, right, you need to have reachability to your peer, right? It could be directly connected, indirectly connected, doesn't care. As long as if 400 can reach to this 1.1.1, even though they're not directly connected, you can still have a BGP configured on them, right? So that is the first condition you need to meet. So now that I already have reachability on my directly connected interfaces, so I'm creating eBGP on that. So conft, I will say router BGP. What is my number here? 400. My neighbor 172.158.1.1. Remote AS is 100. Then I'll put a description here. Description router 2. Right. Let's see what happens. And I will say and assurance at BGP. This is my configuration. Let's go to the router 2 and configure eBGP pair connect router BGP 100 neighbor 172.168.1.2 remote is 400 and the description router 4. Right, so let's confirm my configuration here. Neighbor so and so show IP BGP summary. Let's see what happens here. So let's clear the BGP. Star soft. Right, let's see what happens if I change anything here. Still idle. Let's ping my peer if I have reachability. My bad, again I gave incorrect IP address here. So let's go and fix that. So how will you do that? I would go here, show run sec, connect. So you got to be very careful while inputting this command. BGP, I will say no neighbor. Then I will go and fix this one. 158, 1.2. Description router 4. And let's confirm we have everything as needs to be. Right. Let's clear the BGP here one more time. Alright, so just bear with me. BGP is not the fastest conversion protocol, right? It takes time. Alright, so looks like our BGP is up, but we are not advertising. We are not receiving any prefixes from our peer router 4, right? So if you remember, just by creating BGP by default would not bring everything into the BGP routing table. Basically, you have to go and give that redistribute command. Right. So show IP BGP summary. Alright. Show IP BGP summary. Right. So we are receiving 7 prefixes here. If you remember, on router 2 on router 2 we have this redistribute connected command, right? So this is taking care of advertising all those prefixes to router 4, but we don't have that command in router 4. That's why we are not advertising anything to the router 2, right? As you see here, BGP. So we don't have that command here, redistribute connected. So let's go ahead and put that command and see how the magic happens. Connect router BGP400 redistribute connected. So I'll clear this BGP one more time and see. Just before I cleared and put that command, we were receiving 0 prefixes. Now let's see if that changes anything here. Show IP BGP summary. Alright, so we are receiving all those 3 routes. Show IP BGP neighbor BGP neighbor, copy this IP address, neighbor IP, receive route. Routes. Right, so we're learning this 4.4.4, 40, and 172.1 routes from here. Alright, so if I do show IP route. On router 2, yeah, we have 40.40 networks from router 4. So if I ping 40.40.40.40, I should be able to reach this networks. So now we have to see this router 4 loopback IPs, right? Let me go to the router 4 one more time. Show IP interface size. This IPs I should be able to learn on router 1 and on router 3 as well as router 5. So we did not do any configuration here, so don't worry about that. So let's see if I'm learning this 4.4.4 IPs on 1.1.1. So now pay attention to this. Something important is going to come up here. I'll let you know what it is. Show IP route. So router 1 has the 4.4.4 routes in its routing table. Oh, sorry. .4, and it can also ping, right? And same thing for router 4 to ping router 1's loopback IP address 1.1.1. But what we need to check is on router 3 if we are receiving any route from router 4. See, we are not receiving anything on route from router 4. Show IP route. Let's filter it more clearly. Right? We're not receiving anything. So the reason why the router 4 routes are not making up to the router 3, they are going to the router 2, right? They're going to the router 1 in the routing table, but it's not going to the router 3. If I go into the router 3, and I have basically routes from router 2, router 3, so it's own route from Ospf. Router 1 routes right 1.1.1, but not the router 4. So the reason is router from eBGP router 2 is learning that 4.4 route, right? And it's giving to its iBGP peer 100 router 1. So when the router 1 received that 4.4 route from router 2, it also comes, that route is also tagged with its AS number, which is AS number 100. So upon looking that AS number information tagged with this, for example, like 4.4.4.4, once again, .4, it's coming with this AS number 100, for example, right? And if I copy this, so this route is going here. So once again, right. So this route is going to router 2, and router 2 is giving to router 1. So when the router 1 receives this route here with the AS number 100, it assumes that, right, it belongs to its own AS number, and it doesn't feel any necessity to pass on this route to another peer which is on the same AS number, right? So this mechanism was put in iBGP for the loop prevention, right? So that's why what it does, it just holds this route into its own routing table, but it doesn't give to its peer router 3, which is on the same AS number, because it doesn't feel it's important to do that. Let me show you what I'm saying here. Show IP route 4.4.4. Right, you see it's learning 172 on this from this peer 2.2.2 loopback interface, right, from BGP AS number 100. Looking that, see, this guy has the same AS number 100, I have the same AS number 100, and then I should not give this route to another peer which is on the same AS number. So how we mitigate that, how we going to resolve that? So there is a command here. Let me go. Right, so I will go here. In a minute I will show you what is the command. Router BGP 100. So there are multiple ways you can do this, right? So either what you can do is you can form a full BGP mesh between router 2 and router 3, right? We can do that. Or what you can do, you can use this command, a route reflector client, right? That's called BGP split horizon rule something. So what it does what I just mentioned a few minutes ago, right? If the router find the routes from the same AS number, learn from its peer on the same edge, it will not move, send it to another peer. So to address that, either we can have full mesh, have a BGP between these two, iBGP, or just put a small command here, route reflector client. It will send that route to the router 3. Right, so I would go here router, so I will just say neighbor 3.3.3 route reflector client and see what happens here. It would basically reset your BGP session. If you see that, BGP would reset between your peer 3.3. It would not reset on the other peer because you didn't put that route reflector client command on 3.3, right? On 2.2, right? You only put on 3.3, so that will reset that. It will tear down the BGP neighbor, but it will come up clear IP BGP stop. Let's see. So the BGP is up. All right. So let's do show IP route. See, it has that route now in its routing table. You see that how the magic happens. Oh, sorry. I should look that on router 3. See, now we have that route in our routing table. It wasn't there before. Now after I put route reflector client, I have the route in my routing table, and I should also be able to ping it. Ping 4.4.4.4. There you go. Right. Same thing. Router 4 should be able to ping to the router 3 loopback IP address. Ping 3.3.3.3. There you go. Now that as you see, we are progressing step by step, right? So far we have established connectivity from router 4 to router 2, router 1 and router 3. Let's see if router 4 is able to reach router 5. I don't think so because we didn't do any configuration, but just to clear your doubt, I will do one more time. I will ping 5.5.5 the loopback. It's not pinging at all. So let's go ahead and bring the eBGP between router 3 and router 5. We did the same way between router 2 and router 4. So show run. Let's see what I have in my BGP config first before I make any changes here. Just a second. All right. So I don't have any configuration of iBGP, eBGP configuration on between my router 5 and router 3. So let's go ahead and build that. Without any further ado, connect router BGP 100 neighbor. So one thing, right? Before you bring the BGP, I prefer to ping my point-to-point IP address, right, and see if I have a reachability and 1.1. Sorry, 1.2. So we have reachability, right? Yeah, and I would like to copy this because I made a mistake last time putting in current IP address and revisiting it. So let's not repeat that mistake. Neighbor, blah blah blah, remote AS. Sure. Remote AS 500. Oh, sorry. Description router 5 and just confirm what you just made changes. All right. It's simple. I mean, there's many more. There's much more configuration you can do on these neighbors, but for the sake of this video, I just want to keep it simple. We basically have everything what I needed, like redistribute connected. So this one command would redistribute everything on all its peers. Without worrying about individual IPs, it will just apply this command to all the peers we are connected to on the configuration we have on. Right. So let's go to the router 5. So the router 5 had this local networks on them. Should run on it. Then BGP. I don't think I have any BGP configuration here. So router BGP 500 neighbor. I'll copy the IP address from here this time. 1.1 sorry, remote AS 100 description router 3, and I will say redistribute connected so that it will advertise all its route. Oh, you know what? Let me just connector caps. All right. Show IP BGP summary. So I'm receiving 12 routes from my peer 1.1, which is router 3, right? And the BGP is up. So let's see what is my routing to show IP route. Basically, have everything. So our task before I started this video, started configuration was to reach to the router 4, right? All the way through this way. So let's see if we are able in a shape to do that. So if I do show IP route in 4.4.4, I have a route and I should be able to ping 4.4.4. There you go. If I do a trace route, place 4.4.4. Sorry. As you see here, it's going 161.1 to my neighbor, 192.168.1. This guy, then 192.168.2, this guy, then 172.161.2, this guy. It's clear. I hope you understand what I'm saying here, right? So now we achieved everything, right? Router 5 is able to reach router 4 IPs through this way, and router 4 should be also able to ping router 5. Ping, there you go. So I hope this video makes sense to you, and you were able to catch up with me. Maybe I was a little bit fast, or maybe I was slow, whatever, just leave the comment. But yeah, so we were able to configure everything and have full connectivity between router 4 to router 5. We don't have any directly connected interface, but using our eBGP from here to here, let me clear this a little bit. Using eBGP from here to here, then iBGP here to here, iBGP here, then eBGP here. You see topology sounds some confusing, but that's how. This is nothing. If you work for a big corporation, their networks will be even more complicated. In the following videos, I will make more in-depth configuration, putting next hop self. There are many other BGP commands, right? Route reflectors, these, that, and all. So many other configuration we'll do in future, but for sake of this video, this is what we were supposed to do, and we did that. Show it out. All right, so router 4 has route to basically everything in the network here, right? So thank you all for your time and patience. So see you in the next video. Thanks.